speaker, Bertrand Toem, he is directeur de recherche at the CNRS and at Montpellier too. So, and his title is on the book.
Thank you. So first I would like to thank the ICM organizers for allowing me to give this talk. It's a great honor to be here. And let me start by mentioning some collaborators related to the mathematics of this talk. So there is Tony Pantev, Michel Vaquier, and Gabriel Bezzosi, and also more recently Daniel Kalak, and some aspects with Ludwig Katzarkov. And the aim of this project is the study of modularized spaces of sheaves on compact-oriented manifolds from the point of view of homotopy theory and deformation quantization. So, in order to explain a little bit more this aim, let me immediately give you the main theorem. It's a simplified version in the sense that it follows from a more general theorem, but it's general enough, I think. So I start with a complex reductive group with the algebra little g. Suppose that I have a fixed G invariant scalar product on G. And X will be a compact-oriented manifold of dimension D. And here I'm using manifold in a rather general sense. So it can mean a compact-oriented topological manifold. And oriented means oriented in the topological setting. Or it can be a smooth projective complex manifold with an orientation in the sense of holomorphic orientation. So a fixed isomorphism between the canonical sheaf and the trivial sheaf. And the theorem states that the modularized space of G bundles on X, bun G of X, suitably considered as derived algebraic stack, possesses a canonical n quantization, and this n depends on the dimension. So the purpose of the talk is to explain and comment this result. Particularly, I want to emphasize these two red things here. So I will give you some ideas about what I mean during the talk. Okay, so that's the plan of the lecture. I'm going to start by general things about deformation quantization, just to explain what I mean about this. I will explain what the theorem says in low dimensions, and how it is related to well-known objects or identified objects. Then I will switch to derived algebraic geometry and will give a little bit of definition of what derived algebraic stacks are and why they are useful. And then I will finish by a sketch of the proof of the existence of this quantization. It's not really a sketch, really, just some ideas. Okay. So, what's a deformation quantization? Well, I put principle, but it's almost a definition, I think. I start with a commutative object, and the deformation quantization is a formal deformation of X into a less commutative object, X H bar. So here, what is maybe a little bit not classical is this less commutative.
No, object is not object. What is object?
You will see in a minute. Okay? It can be a ring, it will be a category later on. Okay, that's a general